All right, today's topic is 2.4 function characteristics, found on pages 74 to 80 in your text. Our curriculum outcome is the same. It's to extend understanding of functions, including algebraic functions, transcendental functions, and piecewise functions, including absolute value. And our lesson objectives: number 1, to learn the difference between even and odd functions. Number 2, to learn how to determine when a function is increasing or decreasing. And 3, to learn how to tell if a function is one-to-one or many-to-one. So a function is considered even if it's symmetrical about the y-axis. So what this means is that what's on the right-hand side of the graph is exactly the same as what's on the left-hand side of the graph, and it's centered around that y-axis. So functions that we've dealt with before that would be considered even are things like x squared, which is just a plain old parabola. And we know that a parabola looks like that, just plain old x squared looks like that. So on the right-hand side and left-hand side, exactly the same. And the other one that you might be familiar with is cosine of x. Now remember, cosine started at the top and went down. And then on the left-hand side, it started at the top and went down. So whatever's on the right-hand side is exactly the same as what's on the left-hand side. So if a function is symmetrical around the y-axis, that means that if you plug in both a positive and negative number, for example, x equals plus or minus 2, into your function, you should get the same result. However, you would also need to do the same to get the same result for 1 and -1 and 3 and -3, etc. So instead of plugging in a specific value for x, we're just going to plug in negative x and see if the function remains the same or not. So a function is considered odd if it's symmetrical around the origin, so not the y-axis but the origin. And so functions that we've dealt with before that are considered odd are something like h of x equals x cubed, and k of x equals sine x. So let's just take a quick look at x cubed. You've seen it before. You know that it looks something like this. So hopefully you can see that this is, in the top right is the same as the bottom left. So if you would make it a reflection straight through the origin, and top right is the same as bottom left. Also, I guess you could have something that looks like this, top left and bottom right. That's also considered to be symmetrical around the origin. And we know that sine x starts at 0, goes up, down, and then back up again, and in the opposite direction it would go down, up, and then down again. So these two things are both considered odd functions. So if a function is symmetrical around the origin, that means that if you plug in both a positive and negative number, for example positive or -2, you should get opposite results. So let's just take one quick look again at that x cubed function. So when x, say, is positive 1, we're going to get a specific height here, which would be 1. But if x is -1, then y is also -1. So if we plug in the same x value with opposite signs, so 1 and -1, we should get the same answer, but also opposite signs. Again, instead of plugging in a specific value for x, we're just going to plug in -x and see if the function remains the same or not. And a graph that is symmetrical about the x-axis is not considered a function because it fails the vertical line test. So if it's symmetrical around the x-axis, it would look something like this, like a sideways parabola. That's symmetrical around the x-axis, but that now fails the vertical line test. And as such, it's actually not a function at all. So here's an example for you. It says, state whether the following functions are even, odd, or neither. So what we're going to do is we're going to plug in a negative x into this function and then compare the original to the new function. So we know that f of positive x is equal to x to the 4th minus 6x cubed. So f of negative x will then be negative x to the 4th minus 6 times negative x cubed. Now, when we're done this, we get x to the 4th, but now we have a negative x cubed, which is just negative x times a -6. That changes it to positive 6x cubed. Now we compare the two functions. This function was x to the 4th minus 6x cubed. This one's x to the 4th plus 6x cubed. In order for it to be an even function, these two things need to be exactly the same. They're not. In order for it to be an odd function, they have to be exactly opposite. They're not, because they both have an x to the 4th that's positive. So the answer to this one is neither. It's actually neither even nor odd. And that's okay, because functions aren't always even or odd, but they could be even or odd. Part B, we're going to find out negative x cubed. And we're going to compare that, or plus 4x, and we're going to see if that's even or odd. So we're going to, again, find g of negative x. And now that becomes negative of negative x cubed plus 4 of negative x. Well, this negative x, when you cube it, it's still negative, and you multiply it by a negative, so we get positive x cubed. And then we get minus 4x. So we compare the two. Negative x cubed plus 4x and positive x cubed minus 4x both have opposite signs, so that makes it an odd function. And I mean, you could always graph these things as well. If you wanted to, you could graph them in any sort of graphing software to see whether they're even, odd, or neither. But we can do it just by plugging in a negative x value. All right, h of x equals tan x minus 4x. And so that means h of negative x, we have to find out what that is. H of negative x is going to be tan of negative x. Don't need that extra equal sign, I guess. Minus 4 times negative x. So tan of negative x, well, is that the same thing as tan of positive x? So you might have to look back at your little diagrams that we drew the other day of tan and see that tan as a graph, it looks something like this. So we've got it increasing from left to right, then there's asymptotes, and then it repeats itself over and over and over again. So I would say that this thing, tan of negative x, is exactly the same as, is not exactly the same, sorry, as tan of positive x. Because if we have a positive x here, negative x is in the opposite quadrant, sort of reflected in the origin. So I'd say that tan of negative x is equal to negative tan of x plus 4x. And again, both signs change, so that makes that an odd function as well. Now our last one is k of x. So if k of x is equal to x to the fourth minus 6x squared, and k of negative x is going to be negative x to the fourth minus 6 times negative x squared. If I take a negative number and I raise it to the fourth power, it becomes positive. Same thing if I take a negative number and I square it, it becomes positive. So here's an example of this function, x to the fourth minus 6x squared. And k of negative x is also x to the fourth minus 6x squared. If you get the same result, that is called an even function. So a function is considered increasing if its height increases as you move from left to right. So here's a little graph of a function. This function is increasing because as you move from left to right, the height of the graph also increases. And that means that a function is considered decreasing if its height decreases from left to right. So something like this would be a decreasing function. So to determine if a function is increasing or decreasing in a specific interval, you simply need to substitute in the endpoints for that interval and then compare your answers. So for example, it says, is the function f of x equals negative x squared plus 4x increasing or decreasing from 3 to 5 and then from negative 1 to 2? So from 3 to 5, I'm just going to find out f of 3, and that's just going to give me the height of the function when x equals 3, and that's negative 3 squared plus 4 times 3. That gives me negative 9 plus 12. That gives me a height of 3. And if I plug in an f of 5, I get negative 5 squared plus 4 times 5. And that gives me negative 25 plus 20. That's negative 5. So moving from left to right, when x equals 3 to x equals 5, I see that my y values are decreasing. So that means it's a decreasing function on that interval. Not throughout the whole graph, but just in that interval. So from negative 1 to 2, I'm going to find the same thing and see what's happening there. I get negative 1 squared plus 4 times negative 1. And that gives me negative 1 minus 4, which gives me a negative 5. And f of 2 is negative 2 squared plus 4 times 2. And that gives me a negative 4 plus 8, which is positive 4. So I'm going from negative 5 to positive 4 when I'm moving left to right, negative 1 to 2. And that means that this function is going to be increasing from negative 1 to positive 2. All right, and finally, our final characteristic. It says a function is considered one-to-one if for every x value on your graph, there is exactly one y value. So it's a one-to-one, one x value for one y value. And a function is considered many-to-one if you have multiple x values with the same y value. So let's take a look at this one-to-one thing. So a function that's one-to-one one x for every y. It would be something like a straight line. So everywhere along this graph, for an x value, you get a single y value. Every single x value has a single y value. And on the other graph, if we're to do a many-to-one function, something like an x to the fourth graph, looks like that w sort of thing. We've seen those before. For a single x value, there happens to be, this is the x value here. There's many-to-one, many x values, have the same, y value. So this x value here has a y value of, say, -1. This x value here also has a y value of -1. This x value here has a y value of -1, and this x value over here has a y value of -1. So many x values with the same y value. What that means is that a horizontal line drawn across the graph can determine whether the function is one-to-one or many-to-one. So if we just drew a horizontal line anywhere across this graph, it only crosses once. So that's a one-to-one function. Across this graph, that's supposed to be horizontal. It crosses many times. That makes it a many-to-one function. And that's not many to values, many to one. So in summary, there are a number of different characteristics that can describe a function. The first one is it could be even or odd. So what you do here is you find f of -x and you compare it to the regular f of x. If you get the exact same thing, that's when it's even. And if you get two entirely opposite things, that's when it's odd. And it can also be neither even or odd. You can have a function that is increasing or decreasing. And remember, this is on a set interval. So the entire function doesn't need to be increasing. Like a parabola increases and then decreases if it's upside down. And to do that, you need to plug in the endpoints of your interval into your function, compare your results to find out whether it's increasing or decreasing. And then you could have a one-to-one or a many-to-one function. And so if it's a sketch of the function, you can just draw a horizontal line, see how many times it crosses, like our picture up here. Horizontal line means that an upside-down parabola is a many-to-one function. And if you're given a number of points, you just need to see if any x values have more than one y value associated with it, or just one y value associated with it. So if your points happen to be like 2, 3, 3, 7, and then 5, 3, this would be a many-to-one function because you have many x values with the same y value. And so your assignment's on pages 79 to 80. Good luck, and we'll see you in class.